Okay guys, this is Mr. Gibson, and what I'm going to show you guys in this video is how you can find the missing side lengths of right triangles using what's called trigonometric ratios, okay? The three trig ratios we're going to talk about are sine, cosine, and tangent, okay? And we're going to have this special little saying here to help us remember these ratios, so, ca, toa, okay? Because sine is the opposite side over the hypotenuse, cosine is the adjacent side, which means next to, the side next to the angle times hypotenuse, and then toa is for tangent, which is opposite side over adjacent side. So you guys are probably going, okay, what does that mean right now? So let's look at this angle B right here. Okay, if I take sine of this angle B, okay, you'll actually plug in the angle B for sine. It will equal the opposite side, which is A, over the hypotenuse. It'll be the same value. Same thing happens for cosine. If I take cosine of this angle right here, B, it will give me a number, which is the ratio of the adjacent side, which is the side right next to the B, which is B, this little lowercase b, over the hypotenuse. Okay, and then finally, if I take tangent of this angle B, it will give me a ratio that is the opposite side, which is A, over B. Okay, and you can see the same thing happening here with the angle A. So A, sine of A is B, there's your opposite, over your hypotenuse. Cosine of angle A, adjacent, which is A, over hypotenuse, and then tangent, which is B, as in the opposite, over A, which is the adjacent. Okay, so we're just going to remember this, so, ca, toa. Alright. Best way to try to figure this out, though, is let's do a few examples. So right here, I'm given an angle, 32 degrees, okay, and I'm given the hypotenuse, which is 10, and because I have this angle right here, and it stares, it looks right at this opposite side right here, x is my opposite side. So the first step is to determine which trig ratio we're going to use. And the one we're going to use is opposite. I have opposite and hypotenuse, so I'm going to use sine. So let me take the sine of 32 degrees, okay? And I'm going to set up my ratio. Opposite is x, hypotenuse is 10. Okay, I have that set up right there. So I've determined it. I've set 2 was just to set up my second step was just to set that up. So let me just rewrite it. Okay, make sure everything's fine. And my third step is I'm going to solve for x. Okay, how do you get something out of the denominator? I multiply. So we multiply 10 on both sides. So I get 10 times sine of 32 equals x. So I actually have this solved at this point. But you guys are probably wondering, what is sine of 32? Well, I'm just going to use my calculator to determine that. So I'm going to just put the same thing in the calculator as I have on my paper. 10 times sine of 32. Hey, let me make sure I'm in degree mode. Okay, I'm good. I'll press enter, and there's my answer. I'm just going to round it to the nearest tenth. So I've got x equals 5.3, okay, because it's 5.299, okay? So in this case, so that was my third step right there, was just to solve and use my calculator, okay? So let's do the next one. In this one, I have an angle right here, okay? This side right here, the missing side, is adjacent or next to the angle. This, the side that's given, is, well, it's opposite of that right angle, so it is a hypotenuse. So my first step is I know I'm going to use cosine. Okay, so because COA, TOA, so CAH, I need adjacent over hypotenuse. So let me set up my ratio. So I have cosine, my angle is 26, equals adjacent, which is x, over the hypotenuse, which is 10.1. Okay. Now we're down to our third step where we're going to solve. So I'm just going to multiply 10.1 on both sides. Okay. So here I've solved for this. And again, I have 10.1 times cosine of 26 equals x. Alright? So I'm just going to solve, plug this into my calculator to solve it. So I have 10.1 times cosine of 26, and I get 9.1. So x equals 9.1. Okay? And that's it. So I used an example here with cosine. Now let's look at this final one. And in this case, I have again a right triangle, and then x is right here on the hypotenuse, and 5 is right here, and it's adjacent. It's right next to right next to the angle 27. So I have adjacent and I have hypotenuse. So again, I know I need to use cosine. Okay. So now let's set it up. Second step, set up my ratio. So I have cosine of 27 equals, well, it's adjacent over hypotenuse, which is x. Okay? So to solve this, I'm not going to multiply necessarily this time. Let's just kind of cross multiply, just to switch things around. So I'm going to have x equals 5 over cosine of 27. But again, I'm just going to put that in my calculator. So 5 divided by cosine of 27. And I get x equals 5.6. Okay? So there's a case where I didn't necessarily have the hypotenuse. I had to find the hypotenuse when I had cosine. And so I just set up the ratio like I usually did. And the solving part would be a little different because we use cross multiplication rather than just multiplying both sides. So let me give you some summary steps here. First step is determine the given side and missing side relation to the given angle. So what do I use? Sine, cosine, or tangent. Okay. Step 2, set up the trig ratio with the missing side and given side. Use the right trig function. Remember SOHCAHTOA. So once I've determined whether I'm going to have sine, cosine, or tangent, I just set up the ratio with the angle given into the function. Okay. And then finally, once I have it set up, I can just solve for the missing side. And to determine the value of the trig function at the given angle, I'm just going to use my calculator. And then once you've done that, you are done with a problem where you're solving a missing side of a trig function. So at this point, you guys should be able to find the missing side lengths of right triangles using trig functions. Okay? Thanks for listening, and do the assignment that's associated with this video. Thanks.